So children, I have already done in my previous video the basic theorems on chords, angles subtended by the chords, cyclic quadrilaterals, tangents, intersecting chords, and so on. Now this video is about a few problems on circles. I will be devoting more time to tangents and intersecting chords in the next video. Let's get started with the first video. So here I have a circle in which AC is the diameter, as you can see, because it's passing through the center of the circle. And we are also given that AC is parallel to ED. Further, we are given that angle CBE is equal to 64 degrees. And we have to find out what is angle DEC. Now, since EC is the diameter, I am joining A and E, which will give me this angle. Since AC is the diameter, this angle AEC is the angle in the semicircle, which is going to be equal to 90 degrees. Now, as you can see over here, I have this angle EBC. What are the endpoints of angle EBC? E and C. Look for another angle whose endpoints are E and C. So you can see this angle EAC is also having the same endpoints E and C, which implies this angle is also going to be equal to 64. Now in triangle AEC, I have two of the angles which will give me the third angle, which is equal to 26. Since AC is parallel to ED, if this angle is equal to 26, this angle is also going to be equal to 26 because they are alternate interior angles. Therefore, I'm getting angle ACE is equal to angle DEC, which is equal to 26 degrees. The second question that I have taken is a slightly lengthy one. So we have a circle where AB is the diameter, that is passing through the center of the circle. Unless and until it is passing through the center of the circle, don't assume any chord to be a diameter. Here AB is passing through the center of the circle, which means AB is the diameter. It's also given to us. And we are also given that DO is parallel to BC. And angle DCB is equal to 120. We have to find angle DAB. First and foremost, when you see this, you know that ABCD is a cyclic quadrilateral. It implies that if this angle is 120, then the opposite angle is going to be equal to 180 minus 120, which is 60, because angle A plus angle C both are supplementary. Opposite angles of a cyclic quadrilateral are supplementary. Therefore, you are getting this angle to be equal to 60. Okay. Now, in this triangle ADO, you can see that AO is equal to DO because they are radii. It implies if this is 60, then if this angle is also going to be equal to 60, which implies that this angle is also going to be equal to 60. You can see this. Angle ADO is equal to angle DAO is equal to angle ADO is equal to angle DAO is equal to 60 degrees. And therefore, the last angle, that is angle AOD, is equal to 60 degrees. Which will imply that triangle AOD is an equilateral triangle. This is what you have in the last bit that you have to prove. Okay. Now further over here, so I will write this is 60, this is 60, we got this as 60. Now if this angle at the center AOD is equal to 60, it implies the angle on the circumference, that is angle ABD, with the same endpoints, this is going to be half of 60, which is equal to 30. Angle subtended on the circumference is half the angle subtended at the center. Now in triangle DOB, you get, because DO is equal to BO, which is DO should be equal to BO, which will imply that angle ODB is equal to angle OBD. Therefore, this angle is also going to be equal to 30. Now, if these two are 30, what are we saying? That because DO is parallel to BC, this is 30, implies this angle is also going to be equal to 30. And this is 30, implies that this is also going to be equal to 30. So you have got, you can also, which is saying that, therefore you are saying angle DBA is equal to angle BDC, which is equal to alternate interior angles, and therefore that is equal to 30 degrees. Now, since AB is the diameter, this angle ADB is equal to 90, and you add one more, that is this is 30, which you just found out. Therefore, angle ADC will be equal to 90 plus 30, which is equal to 120. So the third problem that I have taken, you have a circle, this AB is the diameter given. We are also given that angle BAP is equal to 35 degrees and angle RQP is this angle is equal to 25 degrees. We have to find out angle PRB, that is this angle. We have to find out angle PBR, and we have to find out angle BPR. Okay. So let's get started. The first thing you are going to say is, because AB is the diameter, it implies because you have AB as a diameter, so the angle in the semicircle, that means this angle is equal to 90. If this is 90, it implies this is also equal to 90. Okay. Then, so you have, this is what we have written, that is AB is a diameter, implies angle APB is equal to 90, angle in a semicircle. Now you look at this angle BAP has the endpoints B and P. So with the same endpoints, with your, so you look for another angle, that is angle PRB, this angle, which will be also equal to 35 degrees. So angles in the same segment, Now if you look at triangle BPQ, this angle angle PBR, this angle is an exterior angle, and which means this exterior angle is going to be equal to the interior opposite angle, that is sum of the two interior opposite angles. Therefore, this angle PBR is equal to 90 plus 25, which is equal to 115. So I will write over here, this angle is equal to 115. Exterior angle is equal to the sum of the two interior opposite angles. Sum of the two interior opposite angles in a triangle. Then in triangle BPR, if this is 115 and this is 35, implies angle BPR will be equal to 180 minus that will be equal to 30 degrees. So the fourth question that I have taken is about implementing the equal chords. We have PQ is equal to QR is equal to RS being equal chords. and we have given that angle PTS is equal to 75 degrees. So let's find out these angles. Since angle PTS is equal to 75, the angle, that is angle PTS with the endpoints P and S, and therefore the angle in at the subtended at the center is going to be 2 times 75, which is equal to 150. Also, since PQ is equal to QR is equal to RS, the angle subtended at the center by these three chords are going to be equal, which means this and plus this is equal to this is equal to this. Since these three angles are equal, each angle is going to be equal to 50, 50, 50, that is 150 divided by 3. So I'm going to have this is 50, 50 and 50 over here. So you angle QOR is equal to 50 degrees. Now we have found out angle POS, we have found out angle QOR, and we have to find out angle PQR. So angle PQR, this is the angle we want to find out. So what I do is, you look at triangle QOR. In this triangle, since the sides QO is equal to side OR, these two angles are going to be equal, which means in triangle OQR, you are getting sum of all these angles is equal to 180, out of which one of them is 50 and two are equal. Therefore, angle OQR, this angle and this angle are going to be 180 minus 50 divided by 2, that is equal to 65. So I'm going to get this is 65 and this is 65. So here I got this as 50, 50, 50, and this angle is equal to 65, this angle is equal to 65. Now, because triangle POQ, and you can see triangle POQ and triangle QOR are going to be congruent by SSS postulate, because you have these three are radii and these two are equal sides, implies triangle POQ is congruent to triangle QOR, which will imply that this angle is also going to be equal to 65, and therefore angle PQR is equal to 65 plus 65, which is equal to 130. So this question is a converse of what we did in the earlier question. In this question, you have equal chords, that is AB, BC and CD, which will imply that angle AOB is equal to angle BOC is equal to angle COD. That is like this. These three angles are going to be equal. And also we know, we have already proved in the earlier sum that these triangle AOB and triangle BOC and triangle COD are all congruent triangles by SAS postulate or even SSS postulate, which will imply that angle ABO, this angle and this angle are both going to be equal, which will mean that 132 divided by 2, so this is equal to 66 and this is also going to be equal to 66. Then in triangle AOB, you already know that AO and OB are equal because they are the radii, implies that if this is 66, this is also going to be equal to 66. So we have in triangle AOB, 66 and 66, which will give me the angle AOB, which is equal to 48. So I'm getting 48 and this will be also 48 and this also will be equal to 48. Therefore, angle AOD is 3 times 48, which is equal to 144. Which will imply AOD, that is the endpoints are A and D. Therefore, the angle on the circumference, that is AED, with the same endpoints A and D, will be half of 144, which is equal to 72. Angle on the circumference is half the angle at the center. Therefore, from 2, we are getting angle AEB. AEB, we have been asked angle AEB, that is angle AEB like this. I will use another color. This is angle AEB, which is, you see, angle AEB and angle AOB. The endpoints are the same, that is A and B. One is on the circumference and the other is at the center. That is, therefore, you're going to say this is going to be half of 48, that is equal to 24. And therefore, you will get angle AEB is equal to 24, and angle AOB and angle COD we have already found out, which is equal to 48. So you must remember to go through the properties of parallel lines, triangles, quadrilaterals, and you will find that many times without even using the properties of circles, you may still be able to find out the angles that have been asked. Also remember that at every step you must specify the reason. You may end up losing your marks if you don't specify the reason.